Okay, folks, so we've been using Missouri Wind and Solar for not quite a year now. A couple of different PMAs, several different sets of blades. Let's say several, two sets of blades, the Raptors and the Mach 4s, the aluminum set. Several different hubs though. We've used the 7, the 9, and the 11 hubs. And Thermodyne came onto the channel and said that they would send us some equipment, and so they sent it to us. We got it in the mail today. There's a video with the unbox on it. I may attach it to this video, I may not, I don't know. But what I was going to do is some comparisons of some of the equipment. Since I have the aluminum blades that are actually running on the tower on the Missouri Wind and Solar PMA, I thought I would pull some of the Raptor blades from Missouri Wind and Solar and the Thermodyne blades and kind of do a quick comparison on those just to let people see. So there's a caveat to this before we ever even get started, and that is that I am not an electrical or mechanical engineer. I am simply just a guy that's got into renewable energy. I'm trying to learn, and so you're never going to hear me say I'm an expert in anything. You're not going to hear me say I have the answers. I think the proof is in the pudding, and when we start running some comparable tests with wind speed with factual data, then we'll be able to kind of come to some good conclusions. So I'm not knocking either brand of blades or of PMAs or anything I do in these videos. It's simply my observations, and I'm going to put down some data and I'm going to put it on video so other people can see it as well. So we'll start off with, here is the Missouri Wind and Solar Raptor blades. I'll tell you, I've had those things running in some really high winds. I've never had a problem with them. They've been durable. I haven't broken any. I haven't had a problem. I stated in another video, when I had the 11, the PMA would start to spin up at a really low wind speed, 4, 5, 6 miles an hour in some cases. But I will say this, that I watch these blades in Oklahoma. We have a lot of sustaining winds. Unless the wind is sustaining at a specific mile per hour, so as an example, we have 15 gusting to 25, it will spin up and spin right back down just as fast as it goes up, because my opinion is because of the resistance of the number of blades, the amount of blades. So while it's a good thing if you have a lot of sustaining wind, just a constant flow, they'll do really well. But if you have up and down, you would hear these blades spin up with the gust and then come right back down. So the aluminum blades that we put on the Mach 4s, we didn't have that same kind of problem. I think because, personally, I think it's because of the weight of the aluminum blades and the length. And there's a lot of, once you get those things running in momentum, the aluminum, they carry themselves around. So this is the Raptor. Man, you know what? I've seen video after video after video out there about different blades. So I promise you, I'm not going to smack these things against the concrete. I'm going to try to use some factual information, let you guys get some good examples. So on the Raptor blades, they say Raptor right here where they bolt up. They're pretty durable. You can, if I put a little tension to them. Now that is something that's completely subjective, the tension, but they do flex a little bit, which I don't think is a bad thing. They seem to be good and thick. I don't have any problems with them at all. Like I said, I've used them. So Thermodyne sent me their blades, and here's one of the blades. They look very, very similar between the Raptor and the Thermodyne. There's no markings on the end on these blades. So I'm going to flip this over, and I'll lay it on top where you can kind of see, just a comparison. So that is the difference between the blades. That is the physical characteristics between the blades. So you can kind of make your own determination on, it's pretty simple to see which one's wider. There's the thickness of the blades. I'll hold that up to the camera so you can see the thickness. Pretty substantial difference. And you know what? I don't know. Thinner may be better in some cases with different PMAs. I don't know. This is just very factual. So what I thought I would do was I'd take this red marker, and to be consistent, we only lack about probably 1/2 to 3/4 of an inch difference between these two sets of blades. So what I thought I would do would be to come down here and mark a red line on both those, put a mark there, and then we could have just a general place to measure the distance. I'm going to use digital calipers. I've set them to millimeter. They're set to 0. If I go to that mark on the Thermodyne at the thickest point, I'm showing 6.62 millimeters. And if I go to the red dot right here on the Missouri Wind and Solar and measure at the thickest point, let's see, it shows 5.90 at that specific location. I'm going to flip that over. Say if I go to the other side of that, it's going to be 6.10. So very on that end of the blade, the thickness is very consistent. There's no doubt on the big end, on the base end, that the Thermodyne isn't quite as thick. So I know measurements can be somewhat subjective as well on where you go, so I thought I would weigh these as well. So I've got a hole put on this meter. It's set to 0. I'll take the Missouri Wind and Solar, and it comes in at 1 pound 0.4 ounces. I'm going to mark that down over here. 1 pound 0.4 ounces. Okay. Set that one to the side. I'm going to 0 that again. Got a hole put on it. This blade is 13.2 ounces. That's for the Thermodyne. So, I don't know. It is what it is on the data. There's no doubt. You can see that the Missouri Wind and Solar Raptor blades are definitely wider. I'm going to line these things back up. Put the holes together. There's no doubt that they're wider. And you know what? I'm not an aeronautical engineer, so I couldn't tell you if wider is better. I can tell you what I've heard is wider is better, that the more surface area you have, the better off you are for to have the wind have something to bite into. I also took, it looks like they use the same bolts, I'm not 100% sure, but I also took 2 of them, put the bolts through both to keep them aligned, to give you, it looks like there may be a little bit of difference in the alignment between the way they're made. One may have a little further, you can see on the back side, it looks like the angle may be a little bit different, but I don't know, very similar but yet very different. It looks like the injection molding, if that's what they've used on the just from the appearances, it looks like the Raptors are probably a little better finished out. The edges are a little smoother. They're rounded. I'll tell you now, if these things are spinning at 300 to 2,000 RPM, which is what we hear broadcast all the time, you don't want to be anywhere near them because it'd be like a razor blade slicing through the air, so you're going to lose an appendage. So that's kind of the blades. What I thought I would do was also, I just so happen to have one of the hubs from Missouri Wind and Solar, and you can tell this one's painted as recommended, and you can see where I used to have the blades mounted. I thought I would weigh this and see, you know, kind of what the weight was in comparison to the other. So I zeroed that out, and it looks like we've got 3 pounds 11 ounces. So I'm going to put over here, the hub is 3 pounds and what did I say, 11 ounces. Okay, so we'll set that over to the side. Now I haven't even pulled out the Thermodyne hub yet. I wanted to wait and do that on the camera. I'll let everybody know that I paid for my equipment from Missouri Wind and Solar. Tell you the truth, I actually drove 5 hours down to Missouri and picked the equipment up myself and paid for it. And Thermodyne has sent this equipment to me for free. I have no vested interest in supporting one company or the other. The whole reason I started the channel and the breezeking.com website was because there was just so much garbage on the internet back and forth between companies about who had the best this and who had the best that, whose PMA had harder cogging, and it was almost like watching an infomercial, you know, where you have the actors that were scrubbing the floor with the cleaner. You know, look how our you know, competitors do things. So that's the whole reason I got started. It just shouldn't be that hard, and if this is something that's going to be good for our country, then, you know, we better start figuring it out. There's a lot of innovative people in America that want to get involved, and I think as a whole, people have been deterred because they just don't know what direction to go. And in the end, there may be a place for both of these products, I don't know, but that's my take on it. So the Thermodyne came with an informative little kit, tell you how to mount the blades. It gives you a picture, tells you which way to put the blades. It's got some verbiage down the bottom about the torque. So it's pretty informative about, you know, how to put your blades on your hub. I'll put that to the side. Hub, it looks very similar, feels very similar. Slide this over. I'm going to zero out my and this hub comes in at 3 pounds and, correction, 2 pounds 14 ounces. So I'm going to put hub, 2 pounds 14 ounces. So it's a little lighter than the Missouri Wind and Solar hub. Out of curiosity, let's get our calipers out again. I'm going to have it on millimeter. I'm going to zero it. 6.44 is what the meter shows. I'm going to bring that back over, zero it again. The Missouri Wind and Solar shows 6.61. 6.61. So let's do this. Let's make it consistent. We're going to say the first hole, the top hole, 6.80, and to the top of the first hole, 6.35. So 6.80 to 6.35. That's the width of the hub. Now, in comparison, that extra weight probably comes from the extra steel. Just trying to see if there was anything. So there's the center. The extra weight probably comes from the fact that the Missouri Wind and Solar hub is a little bit bigger. So I think that's a pretty good coverage of just the blades and the hub. We're still going to do testing. Thermodyne sent us a 12 volt PMA, and they also have in the mail a 24 volt PMA. We're going to do some ground testing against another competitor that's out there. I used this one before. This is from a company called Wind Blue. You know what? I had no problems with it. This is the PMA that got me started, kind of in the renewable energy playing, I guess, you know, to try. I guess a hobby is for a better word. But this thing did great. I ran tons of stuff off of it. It's 12 volts. Had a lot of fun. Learned a lot of things, and this is what I used to test to tell me kind of what the next level was. So I'm going to run this PMA. Slide this stuff down. I'm going to run this Wind Blue PMA against this 12 volt Thermodyne. This shows to be a 5C12 AC Thermodyne PMA. So I'm going to run the two against each other in some comparable tests and see what we come up with. So You know what? I'm enjoying the heck out of this stuff. There's a lot of speculation on the internet, and I honestly hope that people know there's nothing in this for me. Honestly, solar power is I think where the answer's at. I bought none of my solar equipment from Missouri Wind and Solar or from Thermodyne, but the wind stuff has really just been itching at me because I don't have all the answers, and it's frustrating. And I think I'm a pretty tech savvy guy, and if I'm having these kinds of questions and I can't get good answers on the internet, and there's constant bashing going back and forth, then maybe I can get a hold of some of the products, do some analysis, fair comparisons, and let people have the ability to make good decisions. So that's what's in it for me. More to come. Thanks, folks. See you. Bye.